I'm sorry, but in my video on manifolds with boundaries, I define interior and boundary points wrong. What we have to do is look at interior and boundary charts, and then we can extend that to points. So an interior chart, so a chart, U phi is called interior if phi of U intersect the x-axis, okay, I'm going to denote it like that, is empty. So it's interior if when you look at its image under the chart, it's empty. It doesn't intersect the x-axis, the boundary point. So for example, if this is U hat, then back at the manifold, this U is, in fact, a boundary chart under phi. Okay? And it's called boundary if the exact opposite is true. Phi of U intersect x, the x-axis, isn't empty. So it does intersect it. So for instance, that could be the image of a set. That's a boundary chart. And so we say that x is interior if it is in the domain of an interior chart. Okay? So this point right here, it's in an interior chart, so it's interior, and we say that x is boundary if it's in a boundary chart, the domain of a boundary chart. Okay, so right there, I could have a point there, which is in a boundary chart, but it's not actually on the boundary. And that's the distinction that needed to be made, and that's why my definition was wrong. And this is what makes that theorem that I asked you to prove non-trivial. As Crosby's math pointed out, it would be trivial given my wrong definition. So the reason why we have to do this is so that it's chart independent. And as you can prove is that now any interior point can't be a boundary point under any chart. So an interior point, something in the domain of a boundary chart, cannot also be in the domain of an interior chart, and so on. Sorry about that confusion, and this is the actual definition. Thanks.